Welcome. Let's use property of parallelograms to prove some statements. So let's understand the givens here. What we are given is that ABZY, it's a parallelogram. So that's the figure that we have here, ABZY. And in addition, we know that ZY is congruent to BX. So let's put down our diagram. And at last, we know that we have two congruent angles. Angle 1 is congruent to angle 2. What we want to show is that ABZY, it's also a rhombus. We want to show that this figure that we have labeled as a parallelogram, it's also a rhombus. Now, to show that ABZY is a rhombus, we have to show that all sides are congruent. So now we have a strategy. Given the information that we have on our diagram, can we show that all the sides in the figure ABZY are congruent? Now let's think about how we can show that. Let's start by writing down our givens. We know that angle 1 is congruent to angle 2. Then we can think of BXZ as if it was an isosceles triangle. Now, if it's an isosceles triangle, then we know that BX is congruent to BZ. And the reason is the isosceles triangle converse theorem. Now let's think about this for a second. Do not forget that ABZY, it's a parallelogram. And one of the properties about parallelograms is that opposite sides are congruent to each other. And if that is the case, then we can make the following claims. BZ is congruent to AY. Let's put that on a diagram. We can say this is a property of a parallelogram. And in addition, ZY is congruent to BA. And it's the same reason, property of parallelograms. Now let's look at our diagram again. Notice that we have shown that every single side in the quadrilateral ABZY are congruent to each other. That's a big transitive property. Now let's understand what we have done here. We have shown that every single side in this quadrilateral is congruent to each other, and that is enough for us to claim that ABZY was a rhombus. We can say that we have fulfilled the definition of a rhombus. Now let's take a look at the following proof. So here we're given two figures. We are given that QRST, it's a square. So let's show that on our diagram. And if we introduce a new line, the diagonal of a square, we are given that RQST, it's a parallelogram. Let's start by writing down our givens. Now, one property about squares is that its diagonals, they're all congruent to each other. So let's introduce a new diagonal here. Let's call it QS. Then we can claim that TR is congruent to QS. Diagonals in a square are congruent. So let's show that on the diagram. So we know that QS is congruent to TR. But now notice that TR is one of the sides of the parallelogram. And we know that in a parallelogram, opposite sides are congruent. So that implies that TR is congruent to SQ. So let's write down in our proof. Let's call it property of parallelograms. Notice what we have shown in our diagram. We have shown that QS is congruent to SQ, which notice that those are the two legs of the triangle that we wanted to show congruency of. This is due to transitive property. And we are done. Because now we can claim that triangle QSK, it's an isosceles. Because we have shown that QS is congruent to SQ. And we have fulfilled the definition of an isosceles triangle. Hello. If you would like to continue to learn about mathematics, you can check out the videos on the left.